Listen, a slow, steady breath of iron and fire. For nearly 200 years, this one machine hauled trains across continents and spun the wheels of every factory. It has no computer, no spark plug. Just water, heat, and a handful of moving parts working in perfect time. Today we slice one open, in clean light, and watch a fire learn to push. This is how a steam engine works. It begins with a fire. In the firebox, coal or wood burns hot, and the heat does not escape. Long metal tubes carry that heat straight through a tank of water, the boiler. Hundreds of gallons sit close around those glowing tubes. The water warms, then stirs, then rolls. The whole machine is really a way to boil water on purpose and to do it faster and hotter than any kettle ever could. Hold that picture. The fire is only the start. When water boils, it changes. Liquid becomes steam, and steam wants room. A single drop of water expands into more than 1,000 times its volume as gas. But the boiler is sealed, so the steam has nowhere to go. It crowds against the steel walls and the pressure climbs. This is stored force, invisible and patient, pressing on every surface at once. The engine now holds a coiled spring made of nothing but hot, trapped air. Open a path, and it will leap. That path is a small sliding block called the valve. It rides back and forth across two openings, and its only job is timing. At the right instant, it uncovers a port and lets the high-pressure steam rush into one end of the cylinder. A breath of force pours in behind the piston, a smooth metal plug that fits the bore exactly. The valve is the engine's sense of rhythm. Everything that follows depends on it opening and closing at precisely the right moment. Now the pressure finds something it can move. Steam shoves against the piston, and the piston slides down the cylinder. This is the heartbeat of the whole machine. The moment heat becomes motion. The force is enormous and steady, not a sudden bang, but a firm, growing push, like a hand leaning into a heavy door. The piston travels the length of the bore in a fraction of a second. Heat made the steam made the pressure moves the steel. But a piston only goes straight, back and forth. A wheel needs to spin, so the engine borrows a trick from your own knee. A stiff bar, the connecting rod, links the piston to a stub set off center on the wheel, the crank. As the piston pushes out, it swings that off-center pin around in a circle. Straight-line motion becomes turning motion. It is the same way your leg, pushing down on a pedal, makes a bicycle wheel go round and round. Here is the clever part. The valve does not rest. As the piston reaches the end, the valve slides over and switches the ports. Now fresh steam enters the other side and pushes the piston back the way it came. The same stroke that ended one push begins the next. Steam works both faces of the piston out and back, so no motion is wasted. The wheel never waits. Each turn of the crank shifts the valve, and the valve feeds the next turn. But used steam, once it has pushed, becomes dead weight. It must leave before fresh steam can enter. So at the end of each stroke, the valve opens a second path, and the spent steam escapes up the chimney. That sharp puff is the sound you know, the chuff of a working engine, and the escaping steam does one last job. Rushing up the stack, it drags air through the firebox and pulls the fire brighter. The exhaust feeds the flame that makes more steam. A single push is jerky, strong at the start, weak at the ends, so the engine stores motion in a heavy wheel, the flywheel. Once spinning, its weight does not want to stop or speed up. It coasts through the weak moments and smooths every stroke into one even turn. The flywheel is the engine's memory of motion, a reservoir of momentum. It carries the crank past the dead spots, where the piston pauses and hands the rhythm gently back to the steam. An engine that runs free can run away, so it watches its own speed with a simple spinning device, the governor. Two metal balls hang from a turning spindle. As the engine speeds up, they swing outward, lifted by their own motion. That rising swing pulls a lever that pinches the steam supply, just a little. Faster means less steam. Slower means more. With no brain and no wires, the engine quietly holds itself steady. correcting 1,000 times a minute, all on its own. Now the spinning wheel can do almost anything. Link it by rod to a locomotive's driving wheels, and it hauls a mile of freight up a grade. Tie it by belt to a factory line, and it runs 100 looms at once. Couple it to a pump, and it lifts water from a deep mine. The fire never touches the train or the loom. It only boils water. Everything else is leverage, passed hand to hand from heat all the way to the wheel. Watch the whole breath at once. The fire heats the boiler. The boiling water becomes high-pressure steam. The valve opens and admits that steam to the cylinder. The steam pushes the piston. The connecting rod and crank turn that straight push into a spinning wheel. The valve switches, so steam pushes from both sides. The spent steam exhausts up the chimney and fans the fire. The flywheel smooths the motion, the governor holds the speed, and the wheel finally does the work. No microchips, no fuel injectors, just fire, water, and iron, arranged so heat could finally push. The steam engine lifted the whole modern world onto its wheels, one patient breath at a time. Now, when you hear that slow chuff, you will know exactly what is happening inside. Thanks for watching The Cutaway. Stay curious, and we will slice another one open soon.